Good morning, student. Today we are going to discuss about the preparation of the xenon compounds and structure of the xenon compounds. In 8th group elements are noble gases, are inert gases, are 18th group elements. 18th group elements, chemistry second year English medium. Today we are going to discuss about the structure of xenon compounds. Structure of xenon compounds and the preparation of the xenon compound. Here is the first preparation. Here is the xenon difluoride. The xenon react with the fluorine in the presence of 673 Kelvin 1 bar pressure, then form of xenon difluoride. That is the preparation of the xenon difluoride. Di means that the two fluorine atom. Xenon combining with the two fluorine atom, that is also known as a xenon difluoride. Di means that the two. A xenon reactor combining with the fluorine at 673 Kelvin 1 bar pressure, then form of xenon difluoride. Xenon difluoride. Next another one. Second one, a xenon reactor combining with the 2 moles of fluorine, 1:5 ratio. Here is the 1:5 ratio of xenon and fluorine combining with the 673 Kelvin and 5 bar pressure, then form of xenon tetrafluoride. Xenon tetrafluoride. Tetra means that the 4 fluorine atom. That is also known as a xenon tetrafluoride. Next another one, xenon react with the 3 moles of the fluorine at 573 Kelvin, 60 to 70 bar pressure, then form of xenon hexafluoride. Hexa means that the 6. That is the preparation of the xenon hexafluoride. Next another one, xenon difluoride, xenon tetrafluoride, xenon hexafluoride dissolved with the water molecule or reaction with the water molecule or H2O. Here is the first one, xenon difluoride dissolved with the water molecule or soluble in water molecule to form of xenon, and another one hydrogen fluoride. Next one is the oxygen is formed. When xenon difluoride dissolve or soluble in water molecule to form of hydrogen fluoride HF and oxygen and xenon. Next one, xenon tetrafluoride. Xenon tetrafluoride dissolved in water molecule, 12 moles of water molecule, then form of xenon trioxide. Xenon trioxide and hydrogen fluoride. Next one, xenon hexafluoride dissolved in the water molecule to form of xenon trioxide. Xenon trioxide, that is the xenon compounds. Preparation of xenon difluoride, xenon tetrafluoride, xenon hexafluoride, xenon trioxide. That is the preparation of the xenon compound. Next another one, structure of xenon compound. Structure of xenon compound. Here is the first one, xenon difluoride. Xenon difluoride. In xenon difluoride, xenon is the central metal atom. Here is the xenon is the central metal atom. In the xenon central metal atom, the xenon ground state electron configuration NH2, NP6, ND0. That is the ground state electron configuration. That is the xenon ground state electron configuration NH2, NP6, ND0. But xenon is the central metal atom. Xenon first exit state electron configuration NH2, NP5, ND1. Here is the xenon first excited state electron configuration NH2, NP5, ND1. In xenon central metal atom undergo sp3 dehybridization. Here is the central metal atom undergo sp3 dehybridization to form of 5 sp3 hybrid orbital. 5 sp3 hybrid orbital. S orbital 1, p orbital 3, d orbital 1. 3 plus 1 4, 4 1 plus 5. 5 form of sp3 d 5 sp3 hybrid orbital. In central metal atom, xenon undergo sp3 dehybridization to form of 5 sp3 hybrid orbital. In 5 sp3 hybrid orbital, 2 is the bond pair of the fluorine atom. 3 is the lone pair, that is the 3 lone pair, 2 is the bond pair, that is the 5 sp3 hybrid orbital, then form of the linear structure. Here is the xenon bonding with the 2 fluorine atom, then form of 2 sigma bonds with the 2 fluorine atom. Here is the xenon reactor combining with the fluorine to form of 2 sigma bond. Here is the xenon bonding with the 2 fluorine atom to form of 2 sigma bonds with the 2 fluorine atom. Remaining 3 is the lone pairs. 1, 2, 3. 3 is the lone pair atom. 3 is the lone pairs. 2 is the sigma bonds with the 2 fluorine atom, then form of linear structure and undergo sp3 dehybridization. sp3 dehybridization, then form of 5 sp3 hybrid orbital. That is the structure of xenon difluoride. Xenon difluoride. Once again, xenon difluoride. Di means that the two fluorine atoms react with the xenon compound, then form of xenon difluoride. In xenon difluoride structure, xenon ground state electron configuration NH2 NP6 ND0. NH2 NP6 ND0. Next, xenon first excited electron configuration NH2 NP5 ND1. One electron jump with the d orbital. That is the first excited electron configuration. In xenon difluoride, xenon is the central atom, undergo sp3 dehybridization, then form of 5 sp3 dihybrid orbital. 5 sp3 dihybrid orbital. In 5 sp3 dihybrid orbitals are 2 is the bond pair electrons of the fluorine atom. Remaining 3 is the lone pair atoms to form of a linear structure. In central metal atom, bonding with the 2 fluorine atom, then form of 2 sigma bonds. 1, 2. 2 sigma bond, 3 is the lone pair atom. 3 is the lone pair atom. 1, 2, 3. That is the structure is the form of linear structure. It exists with the 2 sigma bonds with the 2 fluorine atom. 3 is the lone pair atom. That is the xenon difluoride. That is the structure of the xenon difluoride. Next, another one. Structure of xenon tetrafluoride. Tetra means that the 4. Xenon tetrafluoride. Here is the xenon react with the 2 fluorine atom. That is the 1:5 ratio. Then it is 673 Kelvin and 5 bar pressure. Then form of xenon tetrafluoride. That is the structure of xenon tetrafluoride. In this xenon tetrafluoride, xenon compound is the central metal atom. Xenon ground state electron configuration NH2 NP6 ND0. NH2 NP6 ND0. Xenon first existed electron configuration NH2 NP5 ND1. But here is the xenon second existed electron configuration NH2 NP4 ND2. NH2 NP4 ND2. In p orbital 2 electron jumping with the d orbital. Then here is the second existed electron configuration consists of the NH2 NP4 ND2. In xenon central metal atom undergo sp3 d2 hybridization. sp3 d2 hybridization, then form of 6 hybrid orbital. 6 hybrid orbital. That is the 6 hybrid orbital is the 2 is the lone pair electrons. 4 is the bond pair electron. That is the 4 fluorine atom bonding with the central metal atom of the xenon. Then form of the square planar structure. Square planar structure. Here is the square planar structure. The central metal atom xenon bonding with the 4 fluorine atom. 1, 2, 3, 4. 4 fluorine atom, then form of 4 sigma bond. Here is the 1, 2, is the 3 and 4. Here is the 1, 2, 3 and 4. That is the 4 bonding of the 4 fluorine atom. That is also known as a bond pairs. Then form of 4 sigma bonds and exist the 2 lone pair electron. Then form of square planar structure. That is the xenon tetrafluoride structure. Once again, in xenon tetrafluoride structure, xenon is the central metal atom. Xenon ground state electron configuration NH2 NP6 ND0. But xenon second existed electron configuration in xenon tetrafluoride structure. Xenon existed the NH2 NP4 ND2. So here is the p orbital 2 electrons jumping with the d orbital. Then here is the xenon tetrafluoride. Xenon is the central metal atom. central atom, it's undergo sp3d2 hybridization. One is the s orbital, p orbital, 3 is the p orbital, 2 is the d orbital, then form of 6 hybrid orbital. Here is the 1 plus 3, 4 plus 2, 6 hybrid orbital. 6 hybrid orbitals are is the 4 is the bond pair electrons of the fluorine atom, that is the form of 4 sigma bonds. Next remaining 2 is the lone pair electrons, then 6 is the hybrid orbital, then form of the square planar structure. That is the exists the 4 sigma bonds, 2 is the lone pair, then form of square planar structure. That is the structure of xenon tetrafluoride. Xenon tetrafluoride. Remaining another one is the xenon react with the fluorine at 573 Kelvin and 60 to 70 bar pressure, then form of xenon hexafluoride. That is the preparation of xenon hexafluoride. But structure of the xenon hexafluoride. In xenon hexafluoride, xenon is the central metal atom. Xenon undergo, here is the xenon second existed electron configuration, NH2, NP3, ND3. Here is the number of s orbital exists the 2 electron, and number of p orbital exists the 3 electron, and number of d orbital exists the 3 electron. Here is the 2 plus 3, 5, 5 plus 3, 8 electrons. So here is the second existed electron configuration, NH2, NP3, ND3. Xenon undergo sp3d3 hybridization. sp3d3 hybridization, then form of 7 hybrid orbital. 7 hybrid orbital. One is the s orbital, 3 is the p orbital, another 3 is the d orbital. Then form of 7 sp3d orbital. 7 sp3d3 hybrid orbital. In 7 sp3d hybrid orbital, here is the xenon bonding with the 6 fluorine atom. That is the form of 6 sigma bonds with the fluorine atom. That is the 1, 2, 3, 4, 5, 6. In central xenon atom bonding with the 6 fluorine atom, then form of 6 sigma bonds with the 6 fluorine atom of central xenon atom. And consists the one is the lone pair atom, then form of pentagonal bipyramidal structure or octahedral structure. Pentagonal bipyramidal structure or octahedral structure. That is the structure of xenon hexafluoride. Hexa means that the 6 fluorine atom react with the xenon atom, then form of xenon hexafluoride structure. That is the structure of xenon hexafluoride. Xenon is the central metal atom. Here is the central metal atom undergo sp3d3 hybridization in third existing state electron configuration, then form of 7 sp3d3 hybrid orbital. Consist the 7 is the bond pair electron, that is the form of 6 sigma bonds. 6 sigma bonds with the bonding of the 6 fluorine atom, 1 is the lone pair atom, then form of octahedral structure or pentagonal bipyramidal structure. That is the xenon hexafluoride structure. Remaining another one, xenon trioxide. Xenon trioxide. Next another one, structure of xenon trioxide. Next another one, xenon trioxide. In xenon trioxide, that is also not tri means that the 3. Here is the xenon combining with the oxygen to form of xenon trioxide. Xenon ground state electron configuration NH2, NP6, ND0 or 5s2, 5p6, 5d0. Here is the xenon ground state electron configuration 5s2, 5p6, 5d0. In xenon compound, that is also known as a xenon trioxide. Xenon is the central metal atom. A xenon third existed electron configuration 5s2, 5p3, 5d3. Here is the xenon third existed electron configuration 5s2, 5p3, 5d3. Here is the 5s2 electron consists of the 2 electron. 5p3 electrons are 3 electron. 3 is the lone pair electron. 5d3 also now exists the 3 is the lone pair electron. In xenon trioxide, xenon is the central metal atom. In third existed electron configuration 5s2, 5p3, 5d3. That is the xenon is the central metal atom. It undergo sp3 hybridization to form a 4 sp3 hybrid orbital. sp3 4 sp3 hybrid orbital, that is the 3 is the bond pair electron, 1 is the lone pair electron. In central metal atom of the xenon compound, third existed electron configuration 5s2 5p3. Here is the 3 is the bond pair electron, 1 is the lone pair electron, 4 is the sp3 hybrid orbital. That is also known as a xenon, a reactor bonding with the 3 oxygen atom. That is the form of 3 sigma bond, 3 is the pi band. One of the double bond consists of 1 sigma bond, 1 pi bond. Remaining sigma, pi, sigma and pi. Here is the xenon bonding with the 3 oxygen atom to form of 3 sigma bonds. Form of 3 sigma bonds with the 3 oxygen atom, remaining 3 pi bonds. 3 pi bonds with the 3 oxygen atom. Then form of the pyramidal structure instead of the tetrahedral, because of in xenon central metal atom exists the 3 is the bond pair electron, 1 is the lone pair electron. But here is exists the 1 lone pair electron, then is the 3 is the bond pair electron. Then form of the pyramidal structure. But here is the bond pair electrons are consisted, then form of the tetrahedral structure. But instead of the bond pair, it exists the 1 lone pair electron. Then here is the form of the pyramidal structure. That is also structure of the xenon trioxide. Once again, in xenon trioxide, xenon is the central metal atom. In xenon ground state electron configuration 5s2, 5p6, 5d0. Next one, xenon third existed electron configuration 5s2, 5p3, 5d3. Remaining in xenon is the central metal atom. Xenon undergo third existed electron configuration. Third exist state, it undergo sp3 hybridization, then form of 4 sp3 hybrid orbital. 1 is the s orbital, 3 is the p orbital. That is also known as a 4 sp3 hybrid orbital. That's are existed xenon central atom bonding with the 3 oxygen atom, then form of 3 sigma bonds with the 3 oxygen atom, 1, 2, 3. Then form of 3 pi bonds with the 3 oxygen atom. 1 is the lone pair, 3 is the bond pair electron. Then form of the pyramidal structure. That is also known as a structure of xenon trioxide. Xenon trioxide. Next oxy compound of xenon oxy tetrafluoride. Xenon oxy tetrafluoride. How is the preparation of the xenon oxy tetrafluoride and explaining with the structure of xenon oxy tetrafluoride. That is the question of annual question. Here is the first preparation of the xenon oxy tetrafluoride. It is prepared by the xenon hexafluoride, dissolved in the water molecule, xenon hexafluoride, dissolved or soluble in water molecule, then form of xenon oxyfluoride and hydrogen fluoride. That is the preparation of xenon oxy tetrafluoride. How is the preparation of xenon oxy tetrafluoride? Xenon oxy tetrafluoride is prepared by the xenon hexafluoride compound. Xenon hexafluoride are dissolved or soluble in water molecule, then form of xenon oxy tetrafluoride and hydrogen fluoride. That is the preparation of xenon oxy tetrafluoride. In xenon oxy tetrafluoride, structure of xenon oxy tetrafluoride. In xenon oxy tetrafluoride, xenon is the central metal atom. The xenon second existed electron configuration 5s2, 5p4, 5d2. That is the xenon central metal atom second existed electron configuration 5s2, 5p4, 5d2. So here is the xenon is the central metal atom. In it undergo sp3d2 hybridization. sp3d2 hybridization, then form of 6 sp3d2 hybrid orbital. 6 sp3d2, 1 is the s orbital, 3 is the p orbital, 2 is the d orbital. 2 plus 3, 5, 5 plus 1, 6. 6 is the sp3d2 hybrid orbital is formed. In 6 sp3d hybrid orbitals are exist the 4 is the sigma bonds with the 4 is the sigma bonds forming with the 4 fluorine atom. Remaining xenon central atom bonding with the one oxygen atom, then form of with the one is the bond pair electron, then here is the form of one sigma bond, one pi bond. That is the xenon central atom bonding with the oxygen atom. Then form of double bond. Double bond consists the one sigma, one pi. That is the form of 5 sigma bonds. 5 sigma bond, one is the lone pair. Totally 6 bond pair electrons. Totally 6 bond pair electron, then form of square pyramidal structure. Square pyramidal structure. Hybridization is sp3d2 hybridization. That's are existed the 5 sigma bond, one is the lone pair, remaining another one is the pi bonds. That is the structure of xenon oxytetrafluoride. Xenon oxytetrafluoride. Once again, it is prepared by the xenon hexafluoride, dissolved or soluble in water molecule, then form of xenon oxytetrafluoride and hydrogen fluoride. In xenon oxytetrafluoride, xenon is the central metal atom. It second existed electron configuration 5s2, 5p4, 5d2. In xenon oxytetrafluoride, xenon central metal atom undergo sp3d2 hybridization, then form of 6 sp3d2 hybrid orbital. Then here is the central metal atom of this xenon bonding with the 4 fluorine atom to form of 4 sigma bonds with the 4 fluorine atoms. Remaining central metal atom of the xenon bonding with the 1 oxygen atom, then form of 1 sigma bond, 1 pi bond. That's are totally 5 sigma bond, 1 pi bonds, remaining 1 lone pair, then form of square pyramidal structure. Square pyramidal structure, that is the structure of xenon oxytetrafluoride. Xenon oxytetrafluoride. Remaining another one, uses of the noble gases. Uses of noble gases. How is the uses of helium, neon, argon, krypton and xenon? That is the first one. Helium uses of helium. Helium is light or inflammable and it is used filling the balloons which are employed for the metallurgical observation. That is the metallurgical observation. Next another one, helium also used as a cryosurgery or cryogenic agent for the experimental to be carried out of low temperature. Remaining another one, helium also used in a gas cooled nuclear reactors. It is also helium also used in nuclear reactor. Remaining another one, it is used as a diluent for the oxygen. Modern diving operators, because of it very low solubility in blood, that is the helium. Here is the He plus O2, that is the mixture of helium plus O2 mixture also used as a diluent for the oxygen. Modern driving opportunities for the, because of it very low temperature or it is very low solubility in the blood. That is the uses of helium. Uses of helium. First one, helium also used in the air bubbles or air balloons to observe the metallurgical observation. Helium also used in cooled of nuclear reactors. Next another one, here is the helium plus O2 mixture also used in diving of the opportunities in the low solubility of the blood. That is also known as a uses of helium. Next another one, neon used. Uses of neon. Here is the neon is mainly used filling discharges of tubes and fluorescent lamps which are used for the advertising purpose. That is the first one. Neon also used filling of the discharge tubes and fluorescent lamps which are also used as a advertising purpose. purpose. Next another one, neon bulbs are used botanical gardens in the greenhouses. That is the uses of neon. Remaining another one, uses of the argon. That is the uses of the neon. Next remaining another one, uses of argon. Argon used for the filling of electric bulbs. Argon also used for the filling of electric bulbs. Here is the argon also used filling of the argon bulbs. Electric bulbs, sorry. Here is the argon also used in the filling of electric bulbs. Next another one, it is used as a provide inert atmosphere. It is also used, argon also used providing of the inert atmosphere during the welding. That is the uses of argon. Next another one, argon also used in the laboratory for the handling substances that the air sensitive. That is the uses of argon. Argon also used in the filling of the electrical bulbs. Remaining another one, argon also providing of the inert atmosphere. Next another one, argon also used in the laboratory for the handling substances that the air suspensive. That is the uses of argon. Next remaining another one, uses of krypton and xenon. Krypton and xenon also used of origin in the high affinity minor camp lamp. That is the uses of krypton and xenon. Xenon also used instead of the origin in the high affinity minor cap lamp. That is the uses of xenon and krypton. Next another one, krypton 85, Kr 85 also used determine the thickness of metal sheets and the plastic sheets. Here is the krypton 85 used to determine the thickness of the metal sheets and plastic sheets. That is the uses of the krypton 85. The krypton 85 used for the determining of the thickness of the sheets, and remaining another one, fiber sheets are plastic sheets. Remaining another one, xenon also used for the filling of the photographic flash tubes. In the photographic flash tubes. That is the uses of xenon and krypton. Remaining last one, radon. Uses of the radon. Radon also used for the radiotherapy of the cancer. Remaining, it is also used to check defect in the steel coating or casting. Here is the radon also used in the check defect in the steel casting. That is the uses of the xenon compound or xenon, argon or inert elements, or uses of the noble gases. Uses of the noble gases of helium, uses of neon, uses of argon and krypton, xenon. Remaining last one is the radon. That is the uses of the noble gases. Okay, thank you. 8th group is the closed or over. Next remaining another new chapter, discuss the another class. Okay, thank you.